Now going over solutions for computing for medicine quiz. Which FHIR resource checks validity of an implementation? So correct answer is conformance, now called capability statement in FHIR R4. So firstly, let us discuss what FHIR is. So FHIR is basically fast healthcare interoperability resources. Let me show you the exact definition. So FHIR stands for Fast Healthcare Interoperability Resources, which is a standard and framework by HL7 for exchanging electronic healthcare data between different systems and applications. It uses modern web standards like REST, defines resources like patient observation or medication as the smallest meaningful unit of data. It facilitates secure real-time sharing of health information by making it easier to connect various healthcare IT platforms and develop innovative health applications. Some key aspects of FHIR is interoperability, resources, RESTful APIs. Yeah, REST basically is representational state transfer. REST stands for representational state transfer. Application programming interfaces, APIs for data exchange, a familiar and widely used approach in web development. Then flexibility, data types, focus on implementability, and you can read more. So basically, FHIR grew resources into categories: administrative, clinical, financial, conformance. Conformance type resources describe system capabilities, constraints, and compliances with profiles. For example, capability statement ensures a server supports required operations like read, search, update on patient. Other options like medication, patient organization are domain resources, not validation resources. Now, model that predicts a target word from context within a window. So the answer is continuous bag of words, CBOW. This is the model that predicts target word from a context within a window. So it predicts a given word, word given surrounding words, context window. Skipgram is the opposite. It predicts context given in a word. Sorry, it predicts context given a word. Yeah. Then we have the bag of words, which sparse counts, no context. Ngram is probabilistic model of word sequences. So clinical example is myocardial, and the underscore with context words acute and infarction. CBOW predicts infarction. Now, inducing low-dimensional dense embeddings, not sparse, achieved by distributed representations. So the explanation we'll be going over. One-hot encoding is sparse and high-dimensional. Distributed representation is words represented as dense vectors in continuous vector space. For example, word to vector, glove, etc. And then we have tokenization, stemming. They don't produce embeddings at all, right? And why it is useful? Dense vectors capture semantics. For example, diabetes closer to hyperglycemia than car. Now, which is not true of one-hot encoding. So options are storage constraints and overfitting due to sparsity, which is true, and does not give fixed length representation, false. This is the answer. So we need to find not true, that is false. So it does not give the fixed length representation, right? Now, what are the true statements for one-hot encoding? Storage constraints and overfitting due to sparsity. Then does not assume independence. It does assume independence to trick wording. Out of vocabulary problem, true. So the explanation is one-hot encoding does give fixed length, that is the length of vocabulary. Major drawbacks are high dimensionality, OOV issues, and no semantic similarity encoded. Then character level embedding among glove, fast text, and word to vec. So the answer is fast text. So word to vector and glove are word level, while fast text is subword, character, and grams, handles morphology, rare words. Example: diabetic, diabetes, diabetology. Fast text will be able to capture the shared roots, diabet, right? Since diabet is common in all of these. So it gets the subword or the character up till a few letters, right? Now, directed acyclic graph. A DAG is a directed acyclic graph, which means it has directed edges and no cycles. So for example, this is a directed acyclic graph. Let me make it. And this is a directed acyclic graph. There are no cycles and it is directed, having directed edges. Using causal inference. Example: smoking to cancer, ontologies, concept hierarchies, and computational workflows, task dependencies. In medicine, DAGs model confounding, for example, asbestos to lung cancer and smoking. This is a directed acyclic graph. Then biomedical named entity recognition, NER, task detect biomedical terms, drugs, diseases, genes, anatomy from unstructured text, categories, disease, drug, gene, procedure, etc. Then distributional hypothesis, words occurring in similar contexts have similar meanings. Foundation of word embeddings, word to vec, glove. Example: glucose and sugar often appear near blood and level embeddings will be close. Then HL7 segments, line segments separated by a delimiter, that is the vertical line. Each begins with a 3-letter ID: MSH, which is the message header, PID, patient ID, and OBX, which is observation. You can see MSH, PID, and OBX. Then we have delimiters, and this is the example you can see. Then parse trees in biomedical NER. Parse tree is basically syntactic structure of a sentence. Consistency passing, noun verb phrases, dependency passing, subject object relations. Example: aspirin treats MI, root is treats, subject is aspirin, and object is MI. Useful for relation extraction. Drug treats disease. Then stemming is an NLP method reducing words to root form by chopping suffixes. Algorithms: Porto, Lancaster, Snowball. Example: running, runs, ran, going to run. Can be crude, may output non-words. For example, studies to study. A wrong word, right? Which is not a word. Then lemmatization reduces word to its dictionary base from form lemma. reduces word to its dictionary-based form, that is a lemma. Using vocabulary plus grammar rules, smarter than stemming ensures our output is a valid word. Example, study is to study. So this is the correct word. Then better to good. So it uses a dictionary-based form. That is a lemma. More computationally expensive but more accurate for clinical NLP than stemming. Now storyboard plus UML for eye check in rural school children. So storyboard is problem is undiagnosed vision issues in rural children. That is poor academic performance. That is causing poor academic performance. Act as a child, school teacher, optometrist, referral hospital, and EHR. That is electronic health record system. Steps, teacher registers children in mobile app. Optometrist then conducts the screening using Snellen chart flashlight. Then records vision results in app. FHIR observation resource. If abnormal, referral generated, that is FHIR care plan and condition. Data synced to central EHR for analytics and government reporting. Now moving on, UML use case diagram. Actors are child, teacher, optometrist, referral hospital. Use case, register vision test, record result, generate referral, update EHR, and then diagram should show interactions and FHIR resource mapping. Then semantic interoperability approaches plus vector space embedding. So we use three approaches. Use standard terminologies, SNOMED-CT, ICD, LOINC, then biomedical ontologies, UMLS, OBO, then vector space embeddings, Word document embeddings to align semantics. So vector space embeddings converts text into numeric vectors in multi-dimensional space. Words close in meaning, vectors close cosine similarity. Then types of word to vec, englobe, sentence for word, and then document embeddings. Example, hypertension vector is closer to high blood pressure than appendicitis. Right now, FHIR, Internet of Medical Records plus profiling. Example, FHIR is IOMR. RESTful APIs exchange standard resources as we discussed here, right? Then enables cross-institution EHR interoperability. Example, conformance resources like capability statement and structure definition. Then administrative resources, patient and organization, clinical observation, condition and care plan, financial claim and coverage. Together, they form a web, internet of records linked across providers. Then profiling example. So profiling is constraining or extending a base FHIR resource for local context. Example, allergy intolerance profile for Indian EHR, restrict substance to values from a value set, food, drugs, and biologics, make criticality mandatory, bind code to SNOMED-CT, allergy concepts, benefits, ensures consistent data capture across implementation. Right. So now let us read through FHIR. So basically, key aspects of FHIR is interoperability. So its primary goal is to enable different healthcare systems to talk or to basically exchange information and use that information with each other, right? And interoperability, the definition is that it is the ability of two or more systems or connections to actually or communities to be able to exchange information and use the information that has been exchanged. So that is why that is one aspect of FHIR. Then we have resources. That is, healthcare data is broken down into defined discrete units called resources, each representing a specific piece of information such as patient, an allergy, or a medication. Then FHIR uses RESTful or representational state transfer APIs that are application programming interfaces, which are used for exchange of data on the internet, right? And is used in web dev. Then flexibility, it combines the best features of previous standards with a focus on ease of implementation and extensibility for new types of data. Now, focus on implementability, it emphasizes practical, easy to implement solutions for developers and implementers in healthcare ecosystem. Why is it important? It allows modern health data exchange faster and easier and more efficient methods, right? Then the app economy, it can easily basically support the app economy for health and improved health outcomes, right? So that's that. FHIR has allowed modern web technologies, REST APIs, JSON and XML, while earlier using HL7, the legacy HL7 for version 2 and version 3, older messaging and document standards. Now simplicity, FHIR is easier to implement with a focus on simplicity, while HL7, which was earlier used, was more complex and prescriptive with a steep learning curve. Then granularity, HL7 focused on exchanging entire messages or documents, while FHIR exchanged in small meaningful resources. And then HL7 is less adaptable or flexible to varied use cases, while FHIR is more flexible and extensible to fit many contexts.